All right. Hi there, this is Jacob Nash. We're back with the review videos, and in this video, we're going to be reviewing limits. So, if you remember what a limit is, we're thinking about when we're talking about limits, values that we're approaching, and that doesn't always equal what the value is. So that's one way to look at it. So if we have a graph like this, and we have something like this, as we're approaching this value, let's just call it A. All right. We approach B, but the actual value is C. So that's what we're talking about, how a limit is different than just an actual value itself. It could be the same, but it sometimes isn't. But the first thing is let's review how we write it. Um, Once again, if you didn't see the other videos, sorry that this is tilted and a little bit delayed. It's the only way I can make the video. We're always going to say limit as x approaches. It's not always x, but usually. X approaches a value of something, like usually a function, and then what is it? So that this L is, what would that be? Um, and how would this look on a graph is kind of what I just drew. As x approaches A, the function goes to L. Um, so you're going to want to be able to determine limits by looking at a graph. I have a whole bit long video that I can put link in the description of specifics. You know, you might look at a graph and you have to always test the left hand and the right hand side limit. So for the actual limit to exist, we have to know this is true. So it has to go to the same thing from the left and the right. That's like the main thing. Now, sometimes you have to solve limits, and there are five main ways to do it. So plug in value, that's the first thing you could do. Second thing is you might have to factor. The third thing is use conjugate. Fourth thing is squeeze theorem. Fifth thing is piecewise thing. I'll just say that for now. And there's really six, the sine x over x thing. So let me tell you about when you would use these different ones. So hopefully you can just plug it in. So what I mean by that is if let's say we had this here, you could simply just plug that in. It works. You plug in 3. Oh, there you go. Yay. So that's what I mean by plug in. But sometimes it's not that easy because you might get it if we had something like this, well, we're gonna have a problem if we plug that in. That's 1 over 0. If we plug in 0. So if you get something like a denominator of 0, you're gonna probably want to factor and see if something can cancel out. If it does, remember to always write x doesn't equal whatever thing you canceled out. Then you might want to use the conjugate. The conjugate is usually used with square roots. Um, it's not the only possibility of when that could happen, but if you want a review about that, please watch the other video I've done. And squeeze theorem, you might think that you might have a clue that you might need to use squeeze theorem if you see something like this. If you look at that, we plug in 0, we would get sine of 1 over 0. Can't do that, but we can't factor do the conjugate because, this is part of sine. So we could use something called a squeeze theorem. I have a complete video about how to do that. But in general, this is the way that you would do it. You would set up an inequality. And in this case, we would put here sine 1 over x because that's what we have for this part. Then you have to make sure that part gets put on 2. So if we put it here, we have to do the same thing to all 3 sides of the inequality. So we have this. It's kind of small. Wrong way. And then you take the limit of this, and this. Or no, you take the limit of only those left and right things. And by squeeze theorem, if the left and right thing are the same, then the middle thing is also the same. And if they're not, then you can even just, your answer can be by squeeze theorem, and you can just state the inequality. Next thing, piecewise thing. Sometimes you'll get a piecewise function, and I have, video on that too, where you can separate it based on what the absolute value. So when we have piecewise thing, if you have an absolute value, so say we have this. This is where we would have to use this technique because it's saying 2 from the left. Well, depending on what the piecewise function is, because that's what absolute value is, we might have to use the absolute value or maybe not. Will it be negative or will it be positive? And I have a video about how you would know that, but that determines what it would be. So you can't just plug in 2 there and just take the absolute value. You might have to consider, will it be negative? And then last thing, I already talked about the limit. I should really put this here. Limit as x approaches 0 of sine x over x equals 1. So if you have anything that won't work for squeeze theorem that has trigonometry, you might consider using this, and you can use something that's similar to u substitution to make this work. And I have a video on that as well. Next, we're going to talk about when is a function continuous? Well, this is just one of those things where you just have to memorize the 3 conditions. First thing is f of a defined? And a function can be continuous over a certain interval, by the way. But we're saying, is a specific value defined? Does the limit exist? And are those 2 things equal? So does the value exist? Does the limit exist? And are they the same? So something like this would not be continuous because the limit exists, but the value does not. Something like this would also not be continuous because the value does exist, but the limit doesn't. And then last but not least, this one is not continuous because of number 3. They both exist, but they're not the same. Next, we're going to talk about continuity on a domain. So what does that mean? On a domain. So a function can look like it's not continuous, but it is continuous on its domain. For example, this function. Well, it looks like, oh, well, the limit doesn't exist at 0. Well, that's true because 1 goes to negative infinity and 1 goes to positive. But this function is considered a continuous function on its domain because this isn't in the domain. So something like this is continuous. I already showed you the 3 examples where they're not, and we call those holes, jump discontinuities. That's where it's not continuous. But if it's just something like that, then it is. So polynomials are continuous on their domains. All trig functions are, including tangent of x. Rational functions, roots, exponentials, inverse trigs, logarithmic. They're all continuous on the domains. Okay, so next we'll talk about a good theorem. No, IVT, which stands for intermediate value theorem. This is a pretty easy one. And I'm just going to be honest, like if these theorems kind of are like, oh, they're actually really not that hard. All you just have to do is understand what it means and just memorize conditions. But I have a good example on the video I was already talking about. So I would urge you to watch that if this is too brief of a description. But we are able to use the intermediate value theorem to say that a function achieves a value. So that can even be zero. So is there an x-intercept? That's not the only thing that we can use for. But um, the three ways to do this, the first or the three conditions for this to work, f has to be continuous on the interval a to b, closed interval. And how do you know if it is? I already said before, for all values in that interval, they must have actual values, the limits must exist, and they must be the same. Second thing is uh, there must be a value in between f of a and f of b. And then last, f of a cannot be the same as f of b. Then, if those things are true by IVT, there is a value c in a b such that f of c equals n. So we're saying that this value c that we were trying to prove is in the interval. For finding zeros, we're able to know that if one one of these is negative or positive, the f of a and f of b. Okay. So we cannot, this is important, we cannot use IVT to show that a value never goes to a theorem, or never, the function never goes to a value. Sorry, can't speak correctly. So that's what we can't do. We can't say it never goes to a value. We can only say that it does. I feel like the camera is going to fall down again. It seems like it moved, but uh, hopefully it doesn't. Um, right. Next thing I'll say is sign analysis test. This is what we can use for our limits that go to infinity. So let's say we have this. This is actually really something that should have been on that list before. If we plug in 9, we get 0 on the bottom. But if we factor, we can't, that doesn't do anything. Can't use the conjugate. We can't use squeeze theorem. There's nothing else we can do. So what we just have to do is say, okay, well, 9 doesn't work. Let's try 9.01, 8.99, and see what happens. And you'll make a thing like this. And you can see, all right, um, what you would end up doing is seeing, okay, one of them is positive, one of them is negative. So that helps you to know whether it goes to positive infinity or negative infinity. Once again, I have more in-depth video on that. Next thing is even if the limit of f of x or g of x doesn't exist, a combination of them could. That's because when you do the combination of them, so let's say, limit of, let's say it was f of x times g of x, we would have to do the left-hand and right-hand side limit to prove it, And if the left does and the right does exist, but the whole thing doesn't, it's kind of hard to explain in words, but you could see an example of where the limit of the multiplied does exist, even though the individual doesn't. So that's something to be careful about. Um, Now we're going to talk about asymptotes. Vertical asymptotes are where um, what you take the limit of gets you infinity. So the one that I wrote before, or negative infinity. So what you take the limit of gets you, that's your answer. If it's a horizontal asymptote, that's where its limit of x approaches infinity or negative infinity. And remember what you do is you multiply everything by 1 over x to the power of the greatest the greatest denominator exponent. You do that for the numerator and denominator, or whatever it is. You multiply 1 over x to the power of greatest denominator exponent. Another thing I'll just briefly say is the limit, a limit that is infinity or negative infinity doesn't exist. Technically, that's true, but if that's your answer, please write that. So it just doesn't exist. Another thing I'm going to say that you'll want to know that I'm just not going to write is um, if you have a question where it says find a value, it's a piecewise function. It says find a value c so that the limit exists at a certain value. I have a video about how to do that. That's going to be an important one. Um, and that's it for limits. So thanks for watching.